So we started looking at the addition and subtraction formulas. Well, now let's follow this through. This does not mean the sine of x plus the sine of y. You cannot distribute the sign through the parentheses. We talked about that at the very beginning of the first video. What the sine of x plus y there means, look on your formula sheet, and at the bottom there, it says the sine of x times the cosine of y plus the cosine of x times the sine of y. What does that mean? That means we're going to plug in the values that each of these matches. So the sine of x, we found that out in the last video. So let's find the sine of x. We found the sine of x there to be 3/5. So let's put in 3/5. Cosine of y, what's the cosine of y? We found that out in the last video too. Cosine of y is 12/13. So 12/13 plus cosine x, we have that up there at the top, 4/5. Sine of y, we have that up at the top, that's 5/13. So we have to multiply, order of operations says I have to multiply my numerators, multiply my denominators first before I add. So 3 times 12 there is 36. And then what is that, 65? And then we got 4 times 5 there is 20. 5 times 13 there is 65. Notice just naturally, if you're doing it correctly, you're going to get the nice common denominator here. And then we can simply add our numerator and write down our common denominator. So if I add my numerator there, I get 56 over 65. And then always look to see if you can reduce that fraction down. If you can't reduce it down any farther, then you are finished. If you can, then you got to make sure that you actually reduce that down. So if you remember, we got that nice math frac button. So if you don't remember, if you can't see it or you can't figure it out, go ahead and punch in 56 divided by 65, hit your math frac button, and see if it reduces down. If it gives you 56 over 65 again, you know that it's not reducible. In this case, it's not reducible. All right, so let's go to the next one. Again, follow the formula on your identity sheet. This does not mean cosine x plus cosine y. This means cosine x times the cosine of y minus the sine of x times the sine of y. Okay, there's no distribution stuff going on in this. This is just the formula of how you get this solution here, how they're equal to each other. So let's plug it in. Cosine x there is 4/5. Cosine of y, well, we found that up here, it's 12/13. Sine of x, oh yeah, we found that already. Sine of x is 3/5. Sine of y, we were given that too in the very beginning of the problem, 5/13. So then what do? We multiply our numerators, so we get 48, because 12 times 4 there is 48. So all over the nice common denominator is 65. And then we can take 3 times 5 there, ends up giving us 15 65ths. Write down the common denominator and subtract your numerators there, and we get 33 over 65. Again, if you can't see if it reduces down any farther, go ahead and hit 33 divided by 65 in your calculator. Hit the math frac button, and it will tell you that it's not reducible down. It says it's 33 over 65 still. So we're finished. Tangent. Now, tangent's very interesting. I gave you 2 formulas for tangent of x plus y. Either you could go back and put your tangents in there, but right now, because I already know what the sine of x plus y is and I already know what the cosine of x plus y, I'm going to probably just go ahead and say that the tangent of x plus y is equal to sine of x plus y divided by the cosine of x plus y. Because we know the tangent is equal to sine over cosine, it's the same angle. So x plus y and x plus y. So what is the sine of x plus y? Well, we found it to be up here, 56 over 65. What is the cosine of x plus y? It is 33 over 65. All right, so remember, how are we going to divide these fractions? We're going to write them out, and we can make it a division problem. And then after we make a division problem, let's make it a multiplication problem by multiplying by the reciprocal of a second fraction there. So doing so, my 65s can cancel out. And so then I can multiply my numerators. I can multiply my denominators. So doing so, I get 56 over 33. And again, you could plug that into your calculator there and hit the math frac button and see if it reduces down or not. But there we have it. So we have the sine of x plus y, the cosine of x plus y, and the tangent of x plus y. In none of these cases did we go ahead and distribute the tan through the parentheses, the cosine through the parentheses, or the sine through the parentheses. These are just simple formulas of what they're equal to. We just wrote them down and put the values inside of them and replaced them. This next ones are exactly the same. I'm going to go to this one here. We kind of did this on the last one here, but let's do it again. We did this at the very beginning of the other video there. So if you remember how we did this, if we're going to simplify this, we could do what we did at the very beginning of the video, but we could also do this and follow the formula through. This is kind of like the sine of x plus y. What is the sine of x plus y equal to? It's equal to the sine of x times the cosine of y plus the cosine of x times the sine of y. So we already know what that value is. We have it in the very beginning of our notes here. So let's see if we can get that to equal that using this formula now. So let's do it. So sine, my x is my very first one here, so it's just pi over 6. Cosine of y, that's the second value here, which is pi over 3. Plus cosine of x, x is here, this is your x and this is your y. So the cosine of x, which is pi over 6, and then times the sine of my y, which is pi over 3. Well, we know what those values are. We can just look them up on our unit circle or on our identity sheet. So the sine of pi over 6 there, the sine of pi over 6 there is 1/2. So I'm going to replace that sine of pi over 6 there with 1/2. The cosine of pi over 3, cosine pi over 3 there is 1/2. I'm using my identity sheet and I'm looking them up. The cosine of pi over 6 there is a square root of 3 over 2. And the sine of pi over 3 is the square root of 3 over 2. So since that's true, now let's just go ahead and what do we do to clean this up? We can multiply our numerators, multiply our denominators, multiply our numerators, multiply our denominators. So square root of 3 times square root of 3 is a square root of 9, which is 3. Common denominator is 4. What do? We add our numerators together, write down the common denominator, reduce down the fraction if we can, and we get it down to 1. What did we say the sine of pi over 6 plus the pi over 3 was at the very beginning? The sine of pi over 6 plus the pi over 3 there. We said the sine of pi over 6 plus the pi over 3 there is right here, 1. So we also use this nice formula of adding these together, and we also got a value of 1. So again, we don't distribute the sign through. We go ahead. We either find the common denominator in here and add these together and figure out the values. Otherwise, we use our formula to find the sign of adding two angles together. All right, so let's do this one. What does this mean? This means I'm going to follow my formula through. This is kind of like the sine of x minus y. So follow your formula through. Sine of x, using your identity sheet, minus the cosine of x times the sine of y. Again, I'm just looking at my identity sheet, at my formulas there. So now I'm just going to follow this through. So the sine of pi over 6 And this says the cosine of pi over 3 minus cosine of x and the sine of y. And the y there is pi over 3. Again, using your identity sheet or your unit circle there, go ahead and figure out the sine of pi over 6 is. So we get 1/2. The cosine of pi over 3 is 1/2. The cosine of pi over 6 is square root of 3 over 2. The sine of pi over 3 there is the square root of 3 over 2. So now I can clean this up, multiply my numerator, multiply my denominator, multiply my numerator, multiply my denominator, square root of 3 times square root of 3, square root of 9, which is 3. Now, with subtraction, we subtract our numerators, 1 minus 3 is negative 2, and write down our common denominator. Reduce that down, 2 goes in negative 2 there, negative 1 times, 2 goes in 4 there twice. So I end up there with negative 1/2. Again, all we did was follow the formula through there. We want to go ahead, if you cannot look up the sine of 15 on your sheet there, but we can rewrite it. How can 15 be rewritten using two numbers and subtracting two values on your unit circle? So look in your first quadrant, is there any two angles over there in degrees that you could subtract and get 15 degrees? Yeah, sure there are. What are they? 45 and 30. If I were to subtract them, do I get 15? Yeah. So we're going to follow our formula through for this because now this is the difference. So I'm going to follow my sine of x minus y through. So the sine of x minus y here is the sine of x times the cosine of y minus the cosine of x times the sine of y. So let's follow that through. So the sine of 15 is equal to the sine of 45 minus 30. And so now we're going to use our formula here and write it out. So what does that mean? It means the sine of 45 times the cosine of y, which is 30 in our case, minus the cosine of x, and x in our case is 45, times the sine of y, which is 30. Well, we know what those values are. What's the sine of 45 degrees? Look on your unit circle or look on your identity sheet. The sine of 45 there is square root of 2 over 2. What's the cosine of 30 degrees? Cosine of 30 there is a square root of 3 over 2. Cosine of 45 there is a square root of 2 over 2. And then what's the sine of 30 degrees there? Well, the sine of 30 degrees there is 1/2. All right, so multiply your numerators, multiply your denominators. Square root of 2 times square root of 3 is a square root of 6. Can't reduce that down. Square root of 2 times 1 there is a square root of 2. And then over 4 there, 2 times 2 there is 4. So you can either leave it like that. Some people like to put it together as one fraction, so it might look like this is another way it might work. So either one of these doesn't matter. However you want to do that. So either square root of 6 over 4 minus the square root of 2 over 4, or square root of 6 minus the square root of 2 all over 4. So you can't reduce these down because these both aren't under square roots. So you got to leave them the way they are. All right, so our goal here was that we could use the angle addition identities to find the sum and difference of angle values. So I've got a worksheet for you to try out. So the 4-3, a worksheet, if you could work on that.